Friends for joining on. Josh, I think you're right. I think we should definitely do a webcomic. Bob and Alice will be the stars. Right here, so we'll do the application window. I'm just sharing my screen here. Let me know if you can or cannot see. I'll go back to the thing here. You should be able to see my screen here now. Nolan, I guess you can join on and tell me if things are looking weird. Appreciate everybody jumping on. So I'm going to be doing a demo of an application that I wrote that would be just, kind of your run-of-the-mill hashed password authentication, any kind of app that you have that has authentication in it with a hash password approach. Then I'm going to show you how I change that application to integrate with the NuID authentication API. And you can follow along. In fact, I'll drop this in the chat really quick. Sorry for... you can follow along kind of where we're going with this on this README. This repository is at our GitHub. NuID, and it's the Node example repository. And notice that I'm not on the master branch. I'm on this client server apps branch under my name. We will get this merged down and we'll get this added into our documentation pretty soon. I also wanted to point out we have a portal, a developer portal at portal.nuid.io. In fact, I'll paste that into this as well, that you can go log into. You can get you can create an account for free. Excuse me. We do have a pricing tier once you get beyond a certain amount of usage on the API, but signing up is free as well. So when you go to our portal, we have a documentation page, which I'm currently on, and that documentation page gives you some information like, your API key. That's also listed on the dashboard front and center as well. My font's like huge on my on my screen here, but I think it's so that you guys can see a little bit better. But if you go to the documentation page, we have a guide of how you would do this integration yourself. And I'm largely going to be following this guide as well. So there's a setup process, getting your API key, installing the right packages from NPM. And then there's an implementation example that shows you, here's how you call our API. And then when you're changing registration, here's what you would need to do. And then if you scroll down a little bit more, you'll see the guide for changing user login as well. I'm skipping through this because this is what my presentation is going to be. I'll show you all of this code here. Down near the bottom, we have links to all of the libraries and the source code, the repositories and whatnot. And then we also have the documentation for the different endpoints. So we have 4 different endpoints for the authentication API. And you can open these up and see examples of how to use those directly as well. So let's jump back over. So the overview of NuID. So if you weren't on with us just recently with Ethan kind of giving an overview of what NuID is. So we provide a trustless authentication service, and we use zero knowledge proofs. And what that means is that we allow you, or we give you the tooling, I guess I should say, to make it so that you never have to send the client or the user's password across the network from your client device to your backend. And so this slots, like I have here, it slots seamlessly into your existing password-based flow. So your authentication, your registration, your login, etc. This essentially eliminates a password breach risk because the password is never leaves the client device, never gets received by your server. You can't put it in your logs accidentally, as Ethan was talking about. You don't store it in your database, any of those kinds of things. And so our Auth API gives you that ability to create the credentials using those zero knowledge parameters that Ethan was talking about that get generated. So we'll talk through that. So the first thing that I kind of wanted to show was we have this app, and if you go to that branch, and you can actually check out the v1 tag if you want to look at it. I have a client set of code. This is a React app that I used with Create React App. I created it that way. We also have a server, which is just a simple Express app. The server is a little bit easier to show, obviously, because client apps can get kind of big kind of quickly. And you'll notice I have just a simple, hashing function here, a digest function for SHA-256. The Express app has some minimal configuration for cores and whatnot. And then we just have 2 endpoints. So this here is for the login endpoint. As you can see, it takes in the email and the password, and it sanitizes the email, downcases it, makes sure there's no spaces on the ends, whatever. We SHA the password. And then, we attempt to find the user based on those parameters. And if we got it, then we return a 200 with the user in the payload. And otherwise, obviously a 401 error. The registration endpoint is also quite simple. We just create the user based on the parameters that were sent in. Pretty simple. And then returning a 201 with the user, otherwise an error. So really, really basic. I'm also using a library called Sequelize, which is a Node.js object relational mapper, which is an ORM, which allows us to talk to SQLite is what I'm using for this demo. And so, as you can imagine, I just have these 4 fields on my user table. All of them, you have to provide a value for, including the password, of course. And then the email, just acts as the key. It's the unique property on the table, which allows us to do lookups. Yes. Now, if we look at this tab here, so this is an example of the app. Well, it is the app running right now with the v1 checkout. So we'll go ahead and do a registration, and we'll just send this guy in here. So we'll send the password. And now what I want to show you is that when I send this, just like a normal registration, so we authenticate correctly, we get to this account dashboard. And if I go and I look at the network panel, you'll notice that in order to register, I have to send all of that data. And of course, when you deploy this, you would want it to be behind HTTPS with TLS or SSL, but we still have to send that password to the server, and it's effectively plain text in that way, which is not ideal. So we'll go ahead and log out, and we'll show that login works as well. And it's not as important that it works, but it is important to recognize that, again, for the login, we have to send the password again. So just pointing out what that looks like. Now, so the first change that we would make in order to integrate with the NuID API would be that we need to add in the different configurations and get the NPM package. And so this diff here shows comparing between the v1 tag and the v2 config tag. A couple of commits here, but you can see it's a pretty basic change. So I add in the API key to my command that runs my server. And that, if you remember correctly, so up at the very top of our documentation page, sorry about the scroll. Yeah, so we have this environment key that you can basically just copy and paste right in to wherever you run it. Of course, we add the NuID ZK npm package, and we want to add that actually to both the client and the server, because both client and server need to utilize functions in that package. We also added node fetch because I like the interface to that a little bit better than some of the other HTTP libraries. Then, so at that point, all I have to do from the server is pull in those 2 libraries. I define the 2 constants for the host for the API, and then bringing in the API key from the environment. And then I just define 2 simple functions for running a GET request or a POST request against the NuID authentication API. And then I don't really need to do much more there. If the response comes back okay, then we decode the JSON. Otherwise, we just reject the request. So that shows the first process. Now, if we go to the next comparison here, we have we're comparing the v2 tag to the v3 tag. So this was changing. This is basically adding to the registration process the integration with NuID. So I'm actually going to scroll to the very bottom here and show you that for the user model, I can expand this, you can kind of see. The user model, all we actually did was we added in a new field, the NuID field, because this is the essentially the public key, or an encoded version of that public key that's easy to store, that we're going to need in the registration process to create a new ID for every user that's generated. And then we will store that in the database so that we can do authentication later. And you'll notice that I had to change the password to allow it to be null now, since we're not actually going to be receiving a password to store. And this demo isn't really going to go into the changes that you would need to make in order to do a full migration. Sorry about that, but happy to talk about it, in the booth later, or if you wanted to private message me, we can jump on a call as well to talk through that. So we'll jump up to the changes that need to get made on the client. So this is the front end component, the registration component. This is the submit handler for my form, this onSubmit handler. So whereas before we were just taking those 4 parameters out of our local React state, first name, last name, email, password, and we were just sending them straight to the server. Now we actually want to do something a little bit different, and that is we're not going to take the password directly off of state and send it. What we're going to do is we're going to create a verifiable or a verified credential using the password. And we're using the ZK library again that was imported, that we brought in the previous step. So then we are associating that to the data that is getting sent. So this, we're just going to call it credential. That's what the server is going to receive. You can call that whatever you want to call it. We called it credential here. So it's a pretty basic change. In other words, we're not going to send the password. We're instead going to send a credential, and that credential is going to be a verified credential generated based on the password. Again, the password is not going to leave the client anymore. It's not going to be sent to the server during the registration process. And then you'll notice that in our registration handler on the server, whereas before we were creating based on the first name, last name, email, password, etc. Now what we want to do is, so we were allowing, basically because of the unique constraint, it would throw if the email was already in use. But we actually don't want to register a new ID if that email has already been taken. So instead we have to do a lookup. So we look to see if are there any users with this email address. And if the count is 0, then we go ahead and we register the user. Otherwise we reject, saying, hey, that email is already in use. Okay. Now, if you look at this register user function, what it first does is it takes the credential from the request and it sends it to NuID. So we post to the NuID /credential endpoint, and we send the credential under this key here, this NuID.credential/verified key. And then the successful response will have a JSON body, which will have this key, this new/ID key in it. And you can take that as the NuID. So when this register NuID function returns, the next promise in the chain can pick up the NuID and then just pass that into the user create parameters. Now notice again, we don't have a password here to store, so it will be null, and that's why we had to make that change before. So it's a pretty simple change if you take it in context that really we're just taking the password client side, creating a verified credential, sending that credential, and then the back end sends that credential off to NuID to the authentication endpoint to create the new credential, and then it will give us back a NuID. And the auth API at that point is actually going to also put that credential on chain So right now we have it running on Ethereum, and there's other options that we can deploy as well. But it's really kind of satisfying that you can go out, you can actually go see it, on the transaction viewers out on Ethereum. That's process. So that's step 2 of 3. So now we'll do the final step, which is now we need to integrate it with the authentication or the login process. So this login, so this diff here shows the difference between the v3 tag, the v4 tag. And there's quite a bit of code in here. Well, it's not too much code. So I'll jump back over to this page here. This is the README. And so there's a little bit more involved in implementing the login process. And if you were here previous and talking, listening to Ethan's presentation, he talked about obviously zero knowledge proofs. But what we need to do in this scenario is we need to take the secret and we need to verify it against a challenge from the prover. And the prover in this case is going to be the NuID Auth API. And so in order to do that, we actually need to add an additional endpoint to our backend server. Not to NuID. There is a challenge endpoint on NuID, but to our own server here, to our app. So we'll add that challenge endpoint so that we can generate a challenge from NuID and return it back to our client. And then the client will use that challenge and the secret that, again, hasn't left the device and generate a proof. And then we'll send all of that information back to our server for the normal login endpoint with the email, the challenge, and the proof. And then that information will be verified with NuID. And if NuID verifies it correctly, then the authentication has been successful. You can issue them a session, etc. So we'll jump back over to the diff. And we'll go to the server first to kind of show that change here. So what you'll notice is that on this right side, I've added a new challenge endpoint. We need to find the user by their email. And so challenge is going to send the email. We're going to send the email to the challenge endpoint so that we can find the user by that email. If we don't find it, we reject it. Otherwise, we go and we fetch from NuID the credential for the NuID that's registered with that user. And then if we got it back, we just return it. Now you'll notice that this challenge is technically a JWT. If you're not familiar, a JWT. If you're not familiar with that, it's a JSON Web Token. It's just an encoding standard that is used to pass payloads of data around. In the JWT world, they're called claims. It's basically just an object with information inside of it. So we've added this new challenge endpoint. And then we've modified, okay, well, so I'll go up and I'll show the change there on the client side. Yes, where did you go? Okay, yeah, so whereas originally in our onSubmit handler, we were taking the email and password and we were just posting it to our login endpoint. Now, what we first do is we post to our challenge endpoint with the email itself. And then if that comes back okay, then we call this function here, which I've kind of pulled out. And that basically what that does, let me back this up a little bit so that's a little bit easier to see. So we take the challenge response that came back, we decode it, so we get the claim information out of it. And this is just a very simple JWT decoder. There are other ways to do it, of course. And then what we use, so we take the claims from the challenge response, the challenge JWT, and then we combine it with the password that is still on device. We're still in the submit process of this login. And we generate a proof from the secret and the challenge, the secret obviously being the password. Once we have that challenge JWT, we have the proof, we are going to send them all back to our login endpoint. So we're posting back to login. We're sending the email, we're sending the challenge JWT, and of course the proof that we just generated. And we will go look at the changes to the login endpoint. So the login endpoint is going to, again, make sure that we have a user. If we don't, return unauthorized. Then we actually have to call NuID, and we have to send the challenge jot and the proof. And if NuID responds back with a 200, then we're good. Then we know that the user has been authenticated, and again, issue them a session, do whatever you need to do. That is basically it. I know that the text on the screen, it looks like there's a lot of changes here. I think if you go visit it in your own browser and you look at the diffs yourself, you'll notice that it's really a small set of changes. One other thing I was going to point out, if you go to the README on that branch, that you'll notice that for each of these three, so integrating with NuID, this is the setup, this was converting registration, and this was converting login. At the bottom of each of these sections, I have a link to browse the code on GitHub at that tag. And I also have a link to view the diff. And the diff, again, is just exactly what I've been showing you here in this conversation. So I believe, so then I was going to actually show you. So let's go ahead and change this. So I'm going to go check out the new code, and I'm going to run the server. We're going to see if this works. Should work. So we'll log out here. My page is going to reload. React is listening again. Okay, so first we'll create a new registration. We'll pull up our network panel. Okay, so now we've been registered. Oh, and I failed to show in one of the diffs, but I also added to the dashboard that we can show you this new ID. It's essentially a public key. So if we go look at the registration request, I'm now no longer sending the password, but I am sending this big object, which we call the credential, which has all of the zero knowledge parameters embedded in it. And then when that gets sent to NuID, the credential is generated, it's put on chain, and then we return you that information, and then you would store that. So if I log out, we will authenticate with the same. And what you'll notice now is that two different requests happened. So a challenge was issued to our local server. That challenge just was sent the email address, and if we look, the response came back this giant, this big jot that came in here, challenge jot. And then we generated the proof based on that challenge and the user's password, and we issued the request with the challenge, with the proof, with the email, but not the password. So again, password never leaves your device. It never has a chance to get into your logs or to be improperly hashed or leaked in whatever way, stored on your server. It's just it's a risk you don't have to worry about anymore. And yeah, so you saw on the response, and of course on the response, we never returned the password in the first case, but we obviously don't need to retain the challenge or the proof or any of those kinds of things. So that, I'll stop my share. That is our demo for integrating your existing authentication flows with NuID. It's a pretty, we think it's a pretty good, pretty simple approach to removing passwords out of your backend, your server, and just decreasing your risk profile immensely, as these are a lot of the things that people are looking for. They want these passwords, these big password lists and whatnot. So I think that is it. Do we have any questions that I did not? I see there's been some chat in the chat. Here comes old Ethan. How you doing, Ethan?
Good. Yes, there's been a couple questions. I think that we were able to address them all. But one thing that I think is probably good to get into, because it always comes up, is, how does this work? Can this work in other languages? You showed us putting it into a Node example.
Yeah.
And that's what we have, published. We have some documentation right now that shows how to use it in the Node example. But as Nolan pointed out, it definitely isn't limited to that. We've got the client libraries that are for your front end, and those are in JavaScript to run in the browser.
Yeah.
But can you explain how, or kind of speak to a little bit how, say somebody has, a PHP backend, would they still be able to use NuID, and what would that look like?
Yeah, it's a good question. So we definitely want to increase our footprint of client libraries that are necessary in order to generate the reference parameters, to generate the verified credential, to take the challenge jot and the secret and create the proof. What we know is that most of the web runs on JavaScript in terms of your front ends, your front end applications. Now, of course, we have mobile applications. So there's languages Objective-C and Swift and Android and Kotlin and all of these kinds of things. So we will certainly be working towards having better client library adoption so that every platform that implements a client library can do it. We felt like JavaScript was the most obvious language to attack in that way. But to your point about the back end, so for anybody who's running PHP or who's running Ruby or Python or Elixir, whatever it is, what you may or may not have noticed is that in our example, there's actually no cryptography that needs to occur on the server. You're just ferrying information from the client application to the NuID auth API. So the only thing you need is an HTTP library, which the vast majority of languages already have in their standard libraries. And of course, there's millions of other libraries that people can get either on NPM or Ruby Gems or whatever it is. So so your backend application doesn't matter what language it's written in. You're really just ferrying HTTP responses back and forth.
Awesome. Well, thanks for explaining that.
Yeah.
And if anybody has other questions about that, you can find us in the booth or in direct chat. We also have a question from Theodore just now, and I was going to see if Nolan could join us.
Yeah, it would definitely be better if Nolan could join on for that answer. Hi, Imran.
See, are we am I live here?
You are live.
You're live.
Okay, excellent. Yeah, that's a great question, Theodore, about cryptographic primitives. The question was, this sounds sort of like you're implementing cryptographic primitives. How are you verifying that it's correct? And, that's actually, it should always be the first question that comes up when you're dealing with this kind of stuff. And ultimately, the answer is that verifying the implementation is twofold. There's validating the theory, right? There's validating the actual protocol and its proof of security, proof of correctness. And with zero knowledge proofs, there's actually a latter phase of that, which is actually proving that it's zero knowledge as well. And so for that verification, that first component of the verification, can really only be done by cryptographer, right? And so we worked with, his name is Professor Katz, Professor Joe Katz, Jonathan Katz. He was at, he's currently at George Mason. I think before he was at University of Maryland, and is a professor of cryptography. And he's ultimately who we worked with to develop and verify the theory of the zero knowledge protocol. And ultimately, it's a pretty direct application of Schnorr's signature scheme, but kind of tweaked to be a non-interactive zero knowledge proof. And so that's the validation of the theory component. And then obviously there is the kind of ongoing and ever eternal validation and verification of the implementation, right? The code that implements that theory. And for that component, it's kind of it is subsequently kind of also twofold. And the steps we take to verify the implementation ultimately consist of property testing, right? Property-based testing, make sure we can generate inputs and verify outputs automatically. So there's kind of a property-based testing component to the verification of the implementation, and then having it third-party audited. And that's not something we've done quite yet, but it is something that we have underway. And so that's it's kind of an ongoing process, and will always be an ongoing process to verify the implementation. But I'm glad that you asked that question, because it is kind of, it is a cryptographic primitive. Ultimately, we expose kind of a high-level misuse resistance sort of API to those cryptographic primitives, but it is a consideration. And anytime you're kind of dealing with authentication and something like a zero-knowledge proof, you want to be sure that you're not leaking here in any capacity. So that's a really good question. I'm glad you asked.
Excuse because I'm not one of the here, but we also use and consume other open source and well vetted cryptographic libraries.
Correct.
Implementation. So we're not a lot of it we didn't create from scratch.
Correct. So in each of the currently supported host platforms, I see each of the currently hosted languages, or supported languages, mostly, for the elliptic curve implementation and so on and so forth, those delegate to the kind of most popular implementations on each of the given languages. So Bouncy Castle, for example, in Java, and the kind of it's just called elliptic, right? So it's the one that Ethereum uses in JavaScript, and I see that pattern. I don't expect NuID to be implementing our own implementations of elliptic curves or the arithmetic directly. We're consuming that from kind of upstream sources. So that's a good point, Ethan. I'm glad you brought that up.
Imran, he discovered that Nolan couldn't make it today, so this is Nolan's
right. There was a very in tune recognition that I had.
Very in tune.
A haircut last night. Yesterday, my hair was much different than it was today. It's kind of the first haircut I've had in quite a while. So those of you who joined us yesterday and saw that will probably not recognize me whatsoever.
Now, this has been a great chat, but I want to transition just for anybody who was interested to hear. We've got Locke coming on now. So first of all, thanks so much, BJ.
Yep.
As we walk through. Anybody who only caught a part of that, we don't currently have a schedule to do it again, but reach out to us. Let us know. We are happy to. I did try to record it, so hopefully we'll have that.
I also recorded it.
Great. So we'll be able to share that. But we're always happy to chat. If you kind of came in at the end and had some questions, let us know on the event, after the event. We're happy to talk by email or get on a call, show you guys. We can run through this again anytime. So thanks, BJ. Thanks, Nolan. And then
thank you, guys.
You're welcome.
Bye, guys.
Thanks everybody for being on.
And then we've got